Good morning, good evening, good afternoon. Welcome to my session, How to Achieve True DevOps by Including Database Automation. Let me start with introducing myself. My name is Preeti Gupta. I am a Vice President at Brown Brothers Harriman, wherein my team is responsible for building highly scalable, event-driven next generation data platform. Outside of work, I do feel passionate about bringing more female representation in the technical space, and I do try to do my bit by sharing my knowledge and volunteering in events, women in tech events such as this one. Okay, so before we begin, a quick housekeeping rule. There is a Q&A at the end of the presentation. I would ask you to put your questions in the comment, and I'll try to take them at the time. So without further ado, let's begin. Okay, so the agenda for today is that we'll go over the DevOps journey. That is, how was the life before DevOps? What is DevOps? And then finally, we'll try to extend it further by bringing database towards DevOps. Then and then we'll see some of the deployment automation tools, database deployment automation tools, and we'll pick one, which is Liquibase, and go over it. Okay, so what was the life before DevOps? We used to follow a waterfall model. This term was first introduced in a paper published in 1970 by Dr. Winston W. Royce. A little history there. As you can see from the diagram, it was a linear sequential model, and the model emphasizes on logical progression of the steps. So each step will be completed before the second step will start. Now, there are obvious pros and cons of this approach. Let's look at the thumbs up of this waterfall approach. It was simple and easy to understand and use. Process and results are very well documented. Phases are processed and completed one at a time. There were clearly defined stages, well understood milestone, and it would allow for early design or specification changes to be made easily. Now, with this approach, I was reading some one of the articles, and it seems Netflix deploy 100 times a day in the production. With this approach, we definitely cannot achieve that. So, what are the thumbs down? This design is not adaptive. There is a delay in testing until the end of the development life cycle. There is no working product in the middle to basically evaluate and see if we are going in the right direction. This was a poor model for a long and ongoing projects. Integration is done in the end with a big bang, and which actually adds to the high amounts of risk and uncertainty. So there was clearly a need to shift from this waterfall model, and that kind of begins the onset or the that brings the idea of DevOps. Now, what is DevOps? This term was first coined in 2009 by Patrick DeBois. DevOps defines a set of practices which basically combines software development along with operation, and which results into a better and a faster quality, which results into a faster and a better quality product. So if you look into the diagram below, it's an infinite loop wherein development team with plan, code, build, and test, and then overlap with operations during release. We'll deploy, operate, and monitor, and the iteration keeps on going. So this focuses on rapid IT service delivery through the adoption of agile and lean practices such as automation, removing unnecessary code, things like that. Now, what was before DevOps and what was after DevOps? What did DevOps bring to the table? So before DevOps, there was a miscommunication between dev and operations team. Once the development is done, it will be given over to the operation team to take over. There was a haphazard code execution. There was delayed software deployments, and there was a need to constantly monitor for application maintenance and performance. And then there was a lot of overhead in terms of bringing tools that can actually do the application monitoring, onboarding, and things like that, and that would add to the operational cost. This design did lack for scope of innovation. There was lower failure recovery rate. We all know that. There was lack of security, and definitely there was no continuous integration. What did DevOps bring after DevOps? We had improved collaboration between the development and operation team. We had a speedy execution. We had rapid delivery, and we had sustained software development, reduced cost, improved innovation, reduced outages, configuration, integration, to name few. Now, I did mention agile few times in the previous slides, and I felt compelled to put this slide here to differentiate that is DevOps agile. So first, let's look at the similarity between the DevOps and agile. methodology. They both emphasize on testing and automation. They both incline towards business productivity, and they both support synergy between the teams or the partners, powerful partnerships. Then they both draw inspiration from lean philosophies, again the clean code, removing unnecessary code, bringing automation to a certain extent. Now, what are the differences between DevOps and Agile? So, a DevOps is a technical practice to achieve end-to-end solution, where an Agile is more about processes like Scrum methodology and sprints. DevOps aligns operation with stability, such as scripting deployments and standardizing app builds, where in Agile, development is with business priority, thus focusing on speeding up the development process. DevOps bridges a gap between the cross-functional teams, meaning development, QA, operations, wherein Agile tries to bridge this gap by daily scrums involving business and the development team together. Uh, with DevOps, aims to faster delivery through automation using Docker, Chef, Splunk, other configuration management tool. Wherein Agile it tries to streamline the delivery using tools like Kanban board, Scrum, extreme programming, test-driven development, and etc. So we said that okay, DevOps is not agile; it's probably an implementation using an agile. And we reached here from waterfall to DevOps, wherein we did bring in some sort of an automation. We did CI/CD. Now let's see, is there anything that is missing in DevOps? Can we extend it further? And that brings me to the core of this presentation, which is DevOps for databases. So in a traditional environment, even now, we see that application code is fully DevOps based, meaning it's all deployment. Everything is done automatically, wherein database codes is still a manual process. So in a conventional application deployment, application code and database, they go have their own pipeline, which is automated versus manual. And the irony is that all the time application code is associated with some sort of database change. So then why not bring them together, right? If the database code is manual, in that say you send the script to the DBA, script will be reviewed, it will be bundle scripts, and then it will be a manual deployment. So that kind of like using with this approach, it's hard to bring the CI/CD in a in its full extent where everything is just together. So now we understand that there is a need for the DevOps for database, but let's look at the challenges also. Why it has not been done? Why is it so different from the application code? So, what are the challenges? Well, what's so special about databases? It's about data. So, data must be persisted before, during, and after the deployment. Rolling back of databases is much more riskier than rolling back an application. We all know that. There is a lack of culture and well established processes. Yeah, database audits always happen towards the end of the workflow. Now, bringing it towards the start would be a cultural shift. Persisting data during a break, like application code, we cannot easily just drop and replace the database. It has to go through a process and a sanity check to ensure that what we rolled back or what we dropped is right. Then we do have the static data and the test data in various environments. Now, if we have these kind of things, then that adds another challenge to this, to bringing in automation for the databases. The database strips, that's one of the important factor in the sense that, and I'm sure a lot of us would agree with that. In case of production issues, it's faster and easier to apply a hotfix in the database than actually making a code change, test it, and then eventually promoting it. And that causes a drift in the sense that your production database is in a different state than your test database, and then there is a lot of mismatch in between. We understood, and just to extend it further or emphasize the challenges with the database DevOps further, I put in this slide wherein Red Kate conducted a survey on a state of database DevOps in 2021 by asking this question to database professionals, which is what would you consider to be the greatest challenge in integrating database changes into a DevOps process? And these are the main ones, which kind of reflects what we just discussed in the previous slides, which is like synchronizing application and database changes, overcoming different approaches to application and database development, security concerns, preserving and protecting business criteria, and keeping up with the speed of delivery of applications. So we understood that there is a need for database DevOps. We understood the challenges within the database DevOps. Now let's look, if at all, with all these criteria we are proceeding, then how do we define database DevOps? So, what is database DevOps? Similar, like the DevOps attempts to bridge the gap between the enterprise development and the operation teams. Similarly, database DevOps will try to identify and streamline the application development and release processes with the database changes. Now, if we bring DevOps to the database, this will definitely lead to a leaner plus faster development process, and this automation enables control over database development by making this deployment process, which is repeatable, reliable, and consistent. So the what we had in the a few slides back, we had two lines for application code and database code, and database code was definitely extending above application code. Now we just have one happy single line wherein we'll commit both application and database code to the source code, we'll validate, we'll build artifact, and we'll automatically deploy. Considering that database changes are about indeed data, then just by the name of it, you can envision that when we say bringing automation to it, there has to be some extra steps than application code. And the next slide basically talks about that. So if it was an application code, what we'll do, we'll check in the application code into source control, such as Git. We'll build the artifacts with some CI tool, let's say Jenkins. We'll store it to the repository wherever we keep our packages, and then we'll deploy using the CD tool, let's say again Jenkins. But what about database artifacts? So we'll check in the code, same as app code to Git, but we will perform database change rule validation. Then we'll build it, we'll store it, and then we simulate the changes to ensure that is this the ideal state we want it to be in, and then we'll deploy it. So the two steps that has been added can be automated, and I did mention automated with Liquibase. So then there has to be some sort of an automation, and are there any automation tools that are available? Following slides will cover that. So there are deployment or database deployment automation tools, and what do they bring to the table? So they'll help you build, validate database scripts. They will enable recovery from error during development. That is, in case of applying wrong statements to the DB. Enable easier understanding of the database environment state. You can run the test to ensure that similar to any application, you would run the unit test cases and things like that. You could do the same here. You can sync database with source control, and you can publish your database artifacts as a package as if it's an application code. There are multiple deploy database automation tools in the market, like Liquibase, Flyway, DB Deploy, Migrate DB, DB Maintain, and so on and so forth. We'll cover, for the purposes of this presentation, I'll be covering Liquibase, which comes into a free and paid version, and we'll be concentrating on the free version. Who doesn't like free? So let's take Liquibase in detail. So Liquibase is an open source solution. It works across various types of databases. It keeps a history of the database changes, and it is used for managing revisions of database schema script. Now, how Liquibase is different from others? So it's Java-based. It's easy to manage and integrate with Java projects. It does support many different database types. It's easy to set up. It does provide database independent migration support, rollback of database change features. It does provide a database diff report, and it can support different changelog format that's you can have. It's a built-in support for XML, YML, JSON, and SQL. Okay, so let's look into the major concepts of Liquibase. So there is a concept of tracking, which is maintained by the tables called database change log and database change log. I do. If you don't get it now, that's okay. I'll be covering in all these sections in detail in the following slides. So just bear with me for some time. There's a concept of tracking, change set, tagging of the database, so change log file, preconditions, and something like assertions, and the context. All these can be taken care of by Liquibase. Let's look at each individual of these in detail. Now, what is tracking? Now, Liquibase maintains two tables: database change log, database change log. What does the change log table has? It contains no primary key. It does contain a composite key which is made out of ID, author, and file name, and it does track which change set have been run or managed by Liquibase. And each row, it tracks each change set as a row, which is identified by a composite key. The other database change log table, it ensures that only one instance of Liquibase is running at a given point of time. Now, these two tables, you can either pre-create it before running Liquibase, or the first time you run Liquibase, it will create these two tables. The default names are these for these tables, but you can very well change it and change it in your Liquibase configuration properties, whichever table you want to use. There's a slight tip on the right hand side, and that's something that you will encounter when you are doing it for the first time. Like if Liquibase script did not exit cleanly, then you will have an entry in this database change log table, which basically ensures that only one instance of Liquibase is running at a time. And if that happens, you can there are Liquibase commands to unlock it, or you can update the state in the database. And I'll be giving a demo towards the end, and these concepts hopefully should be cleared out even further down. Okay, so what is a change set? It is a unit of change that Liquibase executes on a database. Liquibase attempts to execute each change set in a transaction that is committed at the end or rolled back if there is an error. Liquibase runs only change set which are not executed, and it goes to this the previous table, database change log, and tries to see, did I execute this change set? If so, it will not execute it. Each change set is uniquely identified by the author and an ID attribute. And there is a concept of checksums. It's a cool concept in Liquibase. Basically, Liquibase computes a checksum and stores it into this change log table and uses it to see that did anything change in this particular change set. If so, it will try to run it again. Okay, so a little bit more about change set. Each change set contains a change which describes the change refactoring that should be applied to the database. And the best practice is to have just one change per change set. So if you look into the slide below, there is a sample change set which has an ID, which has an author, and which has an optional comment. And then it refers to a SQL file, which is nothing but it could be any file, but in this case, it's a creatable file. And then equal and opposite rollback, which basically drops the table that we created in the change set. Now, what is the concept of tagging a database? So this change type applies to tag a database. So that can be used for further updates or rollback. It will basically tag the current state of the database or version, and then deploy new changes to that tag, or rollback changes that applied after that tag. And it adds another row in this database changelog table. So it's similar to like when we release application, that time there is some version associated to it, like 1.1, 1.2, things like that. So it's a similar concept, just tagging the database. So if I were to roll back, I can just provide which tag I want to go back and roll back. Liquibase will understand that I have to roll back these many statements. It's a cool concept. What is a change log file? So this is the root of all Liquibase changes. So this is a master change log file, which contains all the change log files that Liquibase is managing. And each change log file can have various change sets in it. So the one that the change set that we covered in the previous slide, you can have a change log file 1.0 with, let's say, 5 change sets. And then this is the master change log where you have all the change logs as per the tagging or the release of your application. Okay, Now, there is a concept of precondition in Liquibase, which is basically just an assertion that is will be evaluated before execution of the change set. It can be applied to either a change log as a whole or an individual change set. If the precondition fails, obviously Liquibase will stop the execution. Some of the preconditions are like check your database DMS type, check your current username, check if change set has been executed, check if table has exist, table has column, if view exists, and check if there are any foreign key constraints. So this is a sample precondition check, which is nothing, which just basically says that if the table exists, then drop it. It's just an hypothetical. You can very well do create or replace on a table. Just a hypothetical example to show you the capable precondition capability. Now, what is a context? It's possible to specify for each change set in which context it should be run. Uh, Context value can be specified on Liquibase run, like the way highlighted here. Context can be applied to change set to control which change set will be applied in which different environment, like development, test, production. So if you're familiar with the Spring or Spring Boot applications, there's a concept of context. You can environment per se. You can say that you can have configuration based on environment. For local environment, you can run different context. You can run different configuration, and for production and for development. The similar concept is here that this particular change, since I said the context is local, it will be run only for local. I can very well change it to production or QC or research and development. Now, how do we run Liquibase? There are various ways you can run Liquibase. You can run on demand, that is, you can run command line. You can run it using Ant. You can run it using Maven or Gradle. You can run it automated, like have a Spring listener, Servlet listener, or JE CDI listener. You can run it through Java API, so it can be like it's Java based, so it can be easily embedded and executed through its Java APIs. Okay, so this brings me to the cool part, which is Liquibase in action. So let me go there. So for the purposes of this presentation, I created a small Spring Boot application using H2 database. So if you don't know what is an H2, it's an in-memory database, and it comes out of the box with the Spring Boot applications. So since it's in memory, it's good for POC and demonstration purposes, but not highly recommended for production usage. And if you look into here, these in my screen, these are the H2 specific configuration that I have given here. And the first two are Liquibase specific configuration. So if I say change log here, that means this is my master change log. We saw the concept of master change log, which maintains various change logs in it. So this is in this context, this change log master XML is my master change log. So let's go there. Okay, so this is my master change log, which has various change logs within it, these files, and then when Liquibase run, it will execute these files in this sequence. Let's take the first one, which is create person change log 1. Okay, so this change log has tagging the database. That means I'm saying that after this, tag the current state of database to whatever is there to 1.0, and everything else after that. Insert everything after that, then which I can use for rollback. So if I say rollback to 1.0, everything that is done after rollback will be rolled back. Then a change set, which has an author, which has an ID to it. And then I have an inline statement, inline SQL to create a table. I'm providing the column name and things like that. And then I have an equal and opposite rollback in which I'm trying to roll back and drop this table. Likewise, I have another change log, which basically, which basically again inline again, and it tries to insert the data in that table. Then I have third one, which basically tries to see again a precondition here, which we discussed that it's something that it's an assertion. I'm saying that if the database type is H2, then you update this table and do these operations. Now I'll try to run this and I'll try to show you in the logs how it looks like. Okay. So if you can look into the log, we had three change logs, and you can see here that all these change logs, Liquibase has executed all the change logs successfully, applied all the change logs, and then successfully released the change log. Now I did enable H2 console to show you that how does the table look like. So let me go there and show you that. Okay, this is the console. So I have this database changelog table, which Liquibase created by itself, and it keeps track of all the changes that Liquibase has applied. So we had three change sets, and we were trying to tag the database in the first one. So you can see that it's a tagging the database. The tag is 1.0, and after that, it has applied all the change logs after whatever is executed after that. If I go to database change log, sorry, this table, you will see it has one row which says logged as false because we are done with the Liquibase change that has been applied. Once you are executing, during the execution, you can see that you will have an entry here which says that it is being logged and then who has logged it and who's granted it. Then let's look the table that we actually created through Liquibase. Okay, so it has one entry and it did update. That was the update statement that wherever the name is strong, update it to India. So it did its job. Back to the presentation. Okay, so there are a few tips and tricks. So one of the first things, and then once you start practicing database DevOps, so you will get used to it. But the difficult challenge is that wrong is right, meaning that if a change set has been committed, even if it is wrong, you cannot modify it. Either you roll back first and then rerun it, or you correct the change, or you have another change set which basically corrects whatever has been done by the previous one. So this is something that you will have to keep on trying and keep in mind. So if the wrong change, so it's always good to basically test uh, the update and the rollback all the time, because if the wrong change set hits the production, then you don't want to roll back at the time, and in that case the only solution you will have is to apply the right change set. Now, the context was a cool concept wherein if let's say you have a static file, you want to run per environment those static data. So you can use this context to say that I want to run this in local environment. I want to run this in quality control environment. It's a cool concept. But the thing is that if you have this concept of context, production version will only be tested in production. You will not be that will never be executed before production. So anything happens wrong there, it'll be you will come to know towards the late in production only. So use it's a cool concept, but use it with caution. Unless there is a need, don't use it. Then it is a best practice to have just one change per change set, and I do want to emphasize on this fact because there are some database changes like DDLs, they are auto commits. And if that's the case, like even though Liquibase tries to execute each change set in a transaction, which is either committed or rolled back towards the end. But if something happened during auto commit in between, then Liquibase will not be able to roll back it. So it's better to have one change per change set. I wanted to add some of the references that I have used for your purposes later, and you can refer it to this later. And that brings me back to the end of the presentation and Q&A if any questions that you might have. So I see a question that faster, how respond faster to business or customer needs by enabling your team to deliver smaller, more frequent releases. I would say by bringing DevOps to the extent that you include database changes as well. So if you have more automation in place, so you can spend more time in developing, doing things doing things faster, and then let it a release will happen. Like you will have less time, you will have to put less effort in basically testing the application, because you will have automated scripts that will validate the test. You will have automated deployment tools, so you will use that to deploy your application, so you can reduce the operational side of it and then work more towards developing an application, or the features that you want to deliver. What is the difference between deployment using LeakyBase and SQL? Server data tools, SQL package.exe. I am not fully aware of SQL package.exe. So this was more towards bringing database changes within an application. So it is not managed separately and more targeted towards the team who actually are app dev and manage their database as well. Uh, I am not sure if SQL package.exe you do it as a data as a whole. Like if you have multiple schemas, multiple databases that are getting released and geared more towards the database architects or database professionals. Liquibase is more towards when your application and database combines together. You manage an application and it has a database associated to it. That way you can combine application and database together, and have it released in one go as a package. Whereas looking at SQL package.exe, it looks like it's more towards the database administrator or the people who are actually working across multiple database, multiple schemas, and releasing it in one go. So I would say it's different. The use case is different for Liquibase and for your SQL package.exe. How to include a database in continuous integration process for immediate feedback. Yeah, so that was the idea of the presentation. You want to include the database artifacts. So you want to follow the same pipeline that you had for the application code. You put it into your repository, code repository, let's say Git. You deploy it. You have some CI/CD pipeline. You have Jenkins, where you let's say Jenkins, where you will automatically build it. Then you use Jenkins again to deploy it, and then you finally release it, whichever release management tool you use, which takes the packages and pushes it to the production, right? So with Liquibase, there are various ways you can do it, and one of them is that let's say if you can run Liquibase through command line. So I can actually run the Liquibase script. So I can create a shell script and I can run Liquibase targets, like say update, rollback, using those scripts, and I can create a package out of it. I can run it through my same pipeline, and I can actually invoke those targets. So I can say update when I invoke the CI/CD pipeline. At that time, I will say Liquibase update. So it will update. It will run the update statement. It will bring all those changes and then create a package out of it. And then that package can be used for the same release pipeline, the CI/CD pipeline that you have used before. So do that in the research and development environment. Do an update, do an rollback, and get a feed, and then get a feed. Basically, pass it through the same process as the application, so that like the way you check in the replication code, you get it reviewed. The same way you maintain your database code, check it into the same repository, and push it through the same life cycle. So get it code reviewed, apply it, test it from the update and rollback perspective, and deploy it as a package. Okay, actually, I'm looking. So the question is actually, I'm looking for the easiest and safest way to change our SVN self developed script change delivery method, for instance, that I manage. What do you recommend? Okay, so if I am getting it right, SVN is the code repository tool that you are using instead of Git, I would suppose. Okay. Uh, yeah, I would still say that do explore Liquibase, regardless of whichever code repository you use. Uh, use create a scripts, follow the norms that liquibase suggest, have the concept of change set, change log, provide equal and opposite rollback scripts, and store it into the same svn package. And I'm sure once you, whatever the code, even the code that you have in svn or code repository, there must be a process to finally to basically deploy it, basically to build it, deploy it, and then eventually push it. So follow the same process for the liquibase also, just that your code, it's little different in the sense you would have to use liquibase, you have to use the norms that liquibase provides, store it into the same svn, and eventually use the same process. Liquibase, I'm sure liquibase can be customized to the way you use your other application code. Like we did, we have spring boot applications, and then we use liquibase to manage our database artifacts as well. So now they both run in the same pipeline, and it's all automated. We as an app developers can actually push our database changes as well without any intervention of dba. So explore it further and try to use the same pipeline within the liquibase. I don't know your specific use case, but I'm sure it can be customized and done. I think that was it. Thank you so much for taking your time and listening to my presentation. Hopefully, I was able to highlight the database DevOps and the importance of it, and you would have some takeaway from Liquibase or any other open source. Thank you.